Okay, well, good morning. This is intended for Eric and Joey, who are taking statistics separately from the rest of the classes. And hopefully, I don't sound too frustrated with this. This is like the fifth time I've tried to record this particular video. We're going to be doing a lot of notes for you guys that are on video, and that's because, of course, I've got another class that's happening at the same time that you're taking this, and it gives a chance for both of you to be learning things at the same time. Sometimes I'll record things ahead of time, like this is. If we can get the technology to work the way it's supposed to, we may, in many cases, just be recording from the regular class and you get to watch it the next day then. What we're going to try to do to start with is give you guys a bit of background on what statistics is and where it comes from. When you get to your first test, you're going to see a bunch of multiple choice questions and matching questions that are asking you about some terms. And the first two terms that you want to know are statistics and data. Statistics does just mean the study of information. There are a lot more complicated definitions you can come up with, but basically that's what it is just the study of information. Data is just a fancy word for information. What we try and do in statistics is analyze information and figure out what should we do as a result of it. Pretty much everything I teach, I try to give some sort of a background on. You guys might remember back when you were freshmen, learning all about the history of geometry. Well, today we're going to do a crash course in the history of statistics. Statistics is one of the most recent branches of mathematics. It tells you here that it was first developed in the 17th and 18th centuries. If you think about that, that would be the 1600s and the 1700s. So statistics was developed in Europe at about the same time that America was being colonized. And it was developed as a way of answering questions and solving problems. I'm going to talk about three key questions that were answered at the beginning of statistics. And when we get to that first test, you might want to be able to list off at least a couple of those different questions. One of which is why people were dying of cholera. Today, cholera is a disease that we don't really think of much in America. The places that you tend to hear about cholera are in places like Haiti. It's in third world countries that have poor sanitation. We know today that cholera is caused by polluted water. Back in the 1600s, though, there was a big outbreak of cholera in London, and lots of people were dying, and they were trying to figure out why. And they used statistics to do it. In particular, what they did is they tried to find patterns in those deaths. One person had the bright idea to look at a map and figure out where all the people that were dying of cholera lived. And it turned out that the vast majority of them lived right along the Thames River in London. And they started thinking, so why would that happen? And why would the river make these people sick? Well, this, of course, was back before the days of indoor plumbing and modern sanitation. And what happened before the days of indoor plumbing is when people had to use the bathroom overnight, they didn't go to a bathroom, they used a little chamber pot that was out beside their bed. And in the morning, the first thing they would do is dump that chamber pot out the window, and it would drain right into the river. Then what they would do is they'd go and gather their drinking water for the day from the river. So they were literally drinking their own waste. Now, when I was a kid, I grew up along the Mississippi River, and we used to joke about how we were drinking the wastewater from the Quad Cities and Dubuque. And of course, we won't even talk about when I was in grad school down by New Orleans and all the different cities whose wastewater flows down there. Well, that's why today we have modern wastewater treatment. You go to a treatment facility, the water that comes out of that in most cases is purer than if you drew it straight from a stream. Back in the 1600s, though, it had people's waste in it and it was making people sick. Second of the questions we're going to talk about is how the King of France could be more successful at cards. The king we're talking about is Louis XIII. He was one away from a much more famous king. And King Louis loved to gamble. In particular, he loved to play poker, but he was not very good at it. He kept gambling and losing, betting lots and lots of his own money and losing more and more. When he ran out of his own money, he would take money from the French treasury and he lost that. And eventually, to try and help solve his problem, he commissioned one of the greatest mathematicians of that era, who was a gentleman named Rene Descartes, who is actually better known for inventing graph paper. Rene Descartes invented the theory of modern probability. One of the things he did is he worked out the exact odds of getting every possible hand in poker. And then he worked with the king and sort of coached him on how to be a better gambler, how much he should bet and when he should bet, when he should fold. And by doing that, he actually was able to basically keep the French treasury alive and keep that country from going bankrupt. Now, because of all of the work that Descartes did with computing the odds for poker hands, you'll find that in every stats book ever written since then, including yours, there's problems that deal with poker. The third big question that they were looking at back in Europe in the 1600s and 1700s was predicting the weather. In the 1700s, there was a series of droughts all across Europe. Crops were failing and there were famines where people were starving to death. And because of that, they wanted to know when and where rain would come. Predicting the weather is something we still try and look at today, and we've actually gotten much better at it in recent years. Predicting the weather involves statistics. When you hear something like there's a 70% chance of rain, what that literally means is when conditions were the same as they are now in the past, 70% of the time it rained. And that's statistics that are telling you that information. Now, we have gotten a lot better at short-term forecasts in recent years. The further out you go, though, the more of a crapshoot it ends up being. But predicting the weather, helping the king be a better gambler, and then also why people were dying of cholera, those were the three big questions that they looked at when statistics was first developed. So next we're going to fast forward a while. And we're going to look at when statistics really became an important branch of mathematics, which was in the 19th century, the 1800s, in England. And statistics really grew into a big, important branch then, mostly because England was transforming from an agricultural society to a manufacturing society, the period that we call the Industrial Revolution. Biggest thing that happened during the Industrial Revolution is factories were formed, and those factories wanted to produce good quality products as cheaply as they possibly could. That is something that every industry still wants to do today. People will complain today when factories relocate to third world countries because they can find cheap labor there. But when they relocate, they don't just want to find cheap labor, they still want to produce high quality goods that people want to buy. That's a constant balancing act in industry. You want to make things cheap, but you want to make sure that they're good enough that people will buy them. A few years ago, a bunch of the Garrigan teachers did a tour of the Snap-on factory here in Algona, and we looked at all the different things Snap-on does for quality control. They have serious quality control at Snap-on, and there's a darn good reason for that. If somebody's paying 10,000 bucks for a toolbox, they want to make sure they're getting their money's worth. So every possible step of that manufacturing process, they go back and check and make sure everything is exactly as it should be. Quality control, making good products cheaply, that's the key thing that happened with the Industrial Revolution. At about that same time, the insurance industry really took off. Now, there's lots of different kinds of insurance. The one that usually high school students are the most familiar with is auto insurance. I sometimes will ask people whether they pay for their own car insurance. When you're in high school, chances are you don't. And there's really a good reason for that too. It's because you probably couldn't afford to pay for car insurance if you wanted to. That's because for a high school kid, especially a high school boy, car insurance is really, really expensive. You can get a bit of a discount if you're included as another person on your parents' insurance, and that's why most of the time it is parents that end up paying for it. Once you do pay for your own insurance, you're going to find it's really, really expensive until either you get married or you turn 30. Once those things happen, your insurance rates do go down for car insurance. Now, that doesn't mean that young males are the worst drivers there is, but it does mean that statistically, young males are involved in more costly accidents than other groups. The least expensive car insurance actually is for senior citizens. And the biggest reason that is that old people drive a lot less than younger people, so they have less chance of getting into accidents, whether they're good drivers or not. Now, different kinds of insurance, the rules work differently on it. If you look at medical insurance, women always pay more for medical insurance than men do. That's because women have more things that can go wrong medically, like pregnancy. Men don't have to worry about getting pregnant, and so that's a major expense that the insurance company never has to cover with the man. On the other hand, life insurance is cheaper for women than it is for men. That's because, on average, women live longer than men. And so, what an insurance company always wants to do is they want to make sure they take on enough money in premiums that they're going to cover their cost and then hopefully have a little bit of money left over. So, the insurance industry is another of those big developments in the 1900s. So moving forward again, in the 20th century, statistics really became essential because of the huge amount of information people had to deal with. A lot of times people will call the 20th century the information age. And it's that explosion in information that's really the reason why today statistics is required for almost every field that people go into. I'm going to look at a couple of key things that went forward in statistics in the 20th century, one of which is opinion polls. We're, of course, in an election year right now, and you're always hearing about what's going on in opinion polls. Right now, Joe Biden is leading in the polls. Sometimes people look at that and wonder, how can you trust whether that's right or not? Now, later in the year, interestingly, it'll be right around election time, we're going to talk about exactly how they go about doing election polls. And it turns out that if you do it right, which most of the big companies do, the results almost always are right on the money. That was even true back in 2016 when a lot of people didn't believe the results that they got ahead of time. But the polls right before the election said that Hillary Clinton would probably win the popular vote, but because of the states involved, Donald Trump would win the electoral vote and thus the presidency. And that is exactly what happened that year. Another thing that really came into its own in the 20th century was forensic science, which you should know, of course, means like using science to solve crimes. One of the big things we think about in forensic science is DNA. Now, DNA, of course, is looking at genes. And you should know from biology class that on any one gene, there's 4 different possibilities you can have. You remember those letters like A and G that you would label genes with. Now, if you looked at one gene and you tried to see whether some suspect for a crime was a match for that, you'd never convict anybody of it on one gene. That's because there'd be a 25% chance that anybody matched that gene. You guys should remember from analysis, though, that when you look at more than one thing, you multiply. If I look at one gene, and then a second gene, and then a third gene, and then a fourth gene, what I do is I take 4 times 4 times 4 times 4. I keep multiplying over and over again, and it doesn't take that long before you're into the billions and you have more possibilities than the number of people on the earth. And when you get a big long chain of genes like that, that's how you can show that somebody was the only person that possibly could have committed this crime. One other thing that being in education I'm always aware of is the idea of accountability. You guys remember taking like the STAR test or the Iowa assessments in the past. The whole point of those tests is to show theoretically 2 things. One of them is that I'm teaching you the stuff I'm supposed to, and the other one is that you're actually learning enough of it that you can say that, yeah, you have the basic skills you're supposed to. Now, exactly how accurate those tests are is a completely open question, but they use those to keep teachers accountable for what they're doing. In almost every job, there's some sort of accountability like that that goes into it. Even if you like stay at a hotel, they'll often send a survey out that says, well, was the room cleaned the way it was supposed to be? Was the person at the check-in desk pleasant? They want to make sure that when things happen, they know whose fault it was and can track that. Sometimes we'll call that junk data because it isn't always the most accurate you can have, but it is trying to show that idea of accountability. And that brings us into modern times. Now, I think I mentioned earlier that back when I was at UNI years and years ago, back in the 80s, I never actually took a class that was called statistics. Even as a math major, that was not a requirement. Today, statistics is required for people going into just about everything. The reason it went from even math majors not really taking it to being something everybody took is technology. When we do math in this stats class, we're going to use built-in features on graphing calculators. And it makes doing statistics really, really easy. What that allows us to do is not get bogged down in the math, which is often extremely complicated formulas, but instead to look at the results and interpret them. Figure out, okay, now that I know this number, what does that mean? What do I do with it? And that whole idea of technology, things like graphing calculators or Excel spreadsheets or websites that will do the statistics for you, that makes things much more available to everybody. So that's kind of the quick history of statistics, and it's our first set of notes. We'll go on and learn a lot of other things from there.